This is section 10.1.3. We're going to take a look at phase shift and vertical shift. So we're going to identify the phase shift of a trig graph and identify the vertical shift of a trig graph. Remember, these are our parent functions. We need to have these memorized. So first, let's talk about the vertical shift. Very simple, very straightforward. Just like with other parent functions, if you have a number that's being added to your function, it's a vertical shift. So if it's plus 4, it shifts up 4 spaces. If it was minus 4, it would shift down 4 spaces. So in this case, cosine theta minus 5 shifts down 5 spaces. So if this was the original starting point, you just count 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it just shifts every single value down 5 spaces. Now the horizontal shift, the nice thing about it is when we're trying to find those x values, it does the horizontal shift for us. Now the formula to find the horizontal shift is negative c over b. That's the formula for it. And so we kind of call this horizontal shift the same thing as the phase shift. That's okay. And what ends up happening is, in this instance, negative c over b, negative pi halves over 1, so it's just negative pi halves. If this is our parent graph, what's going to happen is because of this phase shift, it's actually going to shift over, so it moved over negative pi halves. So it starts here, and then it's going to shift over. Everything is going to shift over that negative pi halves. And that's what the phase shift does. So just to kind of see what it would look like, now a period change does affect it. So in this instance, 2 theta plus pi, my period is pi, my phase shift is negative pi over b, right? So it's negative c over b, my c is pi, so negative pi over b. So that means not only is there a period change, but it's also going to get shifted. So there's the period change, right? So that got squished. And then that's going to get shifted over pi halves. So the period change, and then it gets shifted over. Now the nice thing about it is when we graph it, it kind of takes care of everything for us. So in this instance, this is what I mean. Let's say we know it's a sine graph. So this is my parent graph. There's amplitude is 1. There's no vertical shift. Okay, great. And the question is, what are those x values, right? Like, I need to find what these new x values are going to be. Because of this negative pi over 4, this is going to get shifted. This is what it is. But the nice thing about when we put it between 0 and 2 pi, so 0 less than or equal to theta minus pi force, which is less than or equal to 2 pi, if I get theta by itself, the first value becomes the horizontal shift. Whoa! So if I add pi force, so I get pi force is less than or equal to theta, which is less than or equal to, okay, 2 pi over 1 plus pi force. Remember, we have to find the common denominator. So 4 over 4, so 8 plus 1, so that's 9 pi over 4. This value right here, that's my horizontal shift. If I did negative c over b, negative is a positive, that's pi over 4. They're the same value. So by doing the 0 to 2 pi thing, it finds the horizontal shift for you, which is nice. It just makes it easier for us. Okay, so now I need to find my x values. I found that this first one is pi force. This last one is 9 pi force. So now I need to find the middle ones. So add the ends, divide by 2. So pi force plus 9 pi force. That's 10 pi force over 2. The 2 and the 10, so that becomes 5 pi force. Pi plus, so 1 plus 5 is 6. 6 divided by 2 is 3. So that's 3 pi force. 5 plus 9 is 14. 14 divided by 2 is 7. So I know that that's 7 pi force. And you can tell the pattern. It's going up by 2 every time. 2 pi force. So that means I can go through. Now I found my x values. Right? So if I wanted to, so this first one is pi force, and then it's 3 pi force, and then it's 5 pi force, then it's 7 pi force, and then it's 9 pi force. So going through and graphing it, so we have pi force, then we have 3 pi force, that's going to be 5 pi force, that's going to be 7 pi force, and that's going to be 9 pi force. So starts at the center line, goes up, crosses the center line, goes below, back to the center line. And then when you do that, you can just go through and you can graph it. Looking at another one. This one has both the period change mixed in with it, so that's okay though. So my amplitude is 2. Again, my sine parent graph following that pattern. Okay, so it follows that pattern. I need to find what those x values are. So I can put it between 0 and 2 pi. So the original starting value, the original ending value. Add pi halves to everything. Now if I add pi halves to this, common denominator, 2 over 2, so 4 plus 1 is 5. So that's going to be 5 pi halves. Divide everything by 2. So I get that. Okay, so now I'm doing my box thing. These are just the x values, remember. So I get pi force, 5 pi force. So add them together, divide by 2. So pi plus 5, so 1 pi plus 5 pi is 6 pi. Divide that by 2, that's going to be 3 pi force. 1 plus 3 is 4. 4 divided by 2 is 2. So I'm going to leave that as 2 pi force. Now I know we can reduce that down to pi halves, but I like the fact that it's counting by the same number of pi's, if that makes sense. So 1 pi force, 2 pi force, 3 pi force. And it's easy to just determine that this is 4 pi force, which tells me I can make every single one of these tick marks a pi force. The other nice thing about it is, what if I asked you to keep going? Now you'd see the pattern. That could be 6 pi force. That could be 7 pi force, right? But I'm not asking that of you. I'm just saying what's one full rotation or cycle, but you get the point. So we know the amplitude is 2. My horizontal shift, it's the first value in the box, so that's pi force. My period, 2 pi over b, so that's going to be pi. My vertical shift, that's going to be 2. Right? That's my vertical shift there. Now there's a few things that we can do with that. The first is we can move up the center line. Normally the center line starts here, and we could just say, okay, this is now our new center line. And then from there, you can go through and you can graph the points. So you can do this. I'm just following the pattern from sine. Or another way you can do it is you can say, okay, normally it starts here, but now move it up 2 spaces. So normally it starts here, but now move it up 2. Normally it starts here, but now move it up 2. Here, move it up 2. Here, move it up 2. Here, move it up 2. Both ways are fine. Both ways are okay. And then you can... Now, I just want to point out with tangent, same idea, same premise. All the stuff apply. So in this case, vertical shift, it just moved up 5 spaces. The phase shift, same idea, but just remember it's between 0 and pi. But it's still negative c over b. All of that's the same. But if you do the 0 to pi, it finds your first value for you, which is super easy. So what did we learn today? We talked about how to do the phase shift and the vertical shift of our trig graphs. So how do you find the phase shift? You can either find the first value in our little x value box thing, or it could just be the formula negative c over b. And then how do you find the vertical shift? It's what's being added to the function, so the plus d. This does conclude our lesson. If you have any other questions, please leave them in the comments.